Okay, it's working now. Sorry, it must have been just a glitch. So we have differential equations, and you have a syllabus. Now, I want to just double check that everyone has the correct syllabus because I misprinted some syllabi earlier today. And so what you should look for is on your syllabus at the top, it should say differential equations at the top left.
I have the wrong one.
Okay, there you go. And then there's another thing that we would want to check for, but we can trade. What's this one? Numerical methods?
Yeah.
Okay, yeah, I'll take the numerical methods back. Trade you for a differential. Anyone else? Differential? You got differential? Okay, so that is the first thing to look for. The second thing is if you scroll down to textbooks and course materials, it should say a first course in differential equations with modeling applications by Dennis Zill. So that's what it should say. So if both of those things are correct on yours, then you have the correctly printed version of the syllabus. I printed off a batch that were incorrect, and I had to destroy them. But this mistake was just that I had some extra numerical methods syllabi. I wanted to make sure that I didn't give you the wrong one. Okay, so syllabus. We'll go through this relatively quickly, but by law, I have to share with you certain things, so we're going to go through that. You're probably familiar enough with my methods that you know what to expect. So the course description, we have the textbook here. This is what you should be looking for. So if you haven't got one, make sure you get rush shipping, or however you want to do it. If you want to go in with a friend, or you might be able to find it on Ohio Link. If you need to look at it, you can come up afterwards. Let's see. You should have had Calculus 2 as your prerequisite. That should be fine for most of you, I think, all of you. So moving down, there's the class attendance piece. Oh, well, by the way, just a quick note about the top. So you have my contact information, and certainly you can text me. If you do, please do include your name, even if you've texted me before, just in case. You know, if it's the first time for the semester, just remind me who you are so that I don't get confused. Also, if you want to make an appointment with me, I have the little QR code there and a clickable link. Oh, it doesn't click. It clicks if you're online. So, you know, if you go online and go to the Moodle site, you'll find this. You can click it. But anyway, the QR code will get you there as well. And you can make an appointment with me. The benefit of that is, and you're certainly welcome to just pop in, I don't mind. But the benefit of this is that you can be sure that I don't wander off. And also, whenever I have, I have an appointment next week I need to put on my schedule. Like if I have a doctor's appointment, I'm thinking of one that I'm going to go to on Thursday. I'll put that on my calendar. That way you won't be able to make an appointment. You'll be like, well, I guess he's not going to be there. I encourage you to use that as much as you want to, or not. You can pop in. And I'm available as early as 6 a.m. However, like I wasn't here. I think I left my house at 6:30 this morning. So if you really want me to be here at 6 a.m., you'll have to make an appointment. That way you can be sure that I'll be there. And I can make you espresso in my office if that will help you, as well as coffee, hot chocolate, tea. I have all the hot drinks. Okay, getting back to this. So we have the book. We have various objectives that we'll just gloss over. Course policies, we have class attendance. You know what my expectations are is that you come every day. But we're all adults and you make choices. And sometimes you choose to not come. I understand that. The university policy is 3 weeks. If you do more than 3 weeks of a particular course missing, so that's 9 classes here, so that would be 10. If you miss 10 classes, you get administratively withdrawn. And I oftentimes am happy when I see someone with administrative withdrawn, just because usually it's because they haven't communicated and it's like, oh, I don't have to worry about that person anymore. They're not my problem. So I don't think anyone here is like that. Usually, most of you are willing to come and ask for help or let me know that you're going to miss because you're in that foosball thing or whatever it is. Okay, so we have the attendance. We've got late work, same deal as always. Quizzes, no, I don't make up quizzes because it's too much of a pain. But you don't get zeros unless you skip because you're going to snow trails or wherever it is that you're going to And then tests, yeah, just communicate. I'd say all of this stuff, being late. Let me know how things are going, and we'll make sure we accommodate one another. Okay, classroom decorum at the bottom, laptops, cell phones, etc. Are prohibited. But I understand that some of you might prefer to take notes on your, like here. You might have some sort of an app like this, and you're like, I do all my notes, and they're all nicely organized, unlike mine. But you've got them all organized, and you want to do that, that's fine. Just let me know. I've got a couple of students in my calculus class who are going to be doing this, and I have a little sort of covenant, let's say, that I have people. I got it from one of my faculty or one of my colleagues that I thought was kind of neat. That just says that you're going to use it to take notes, and you're not going to be watching the Final Four or whatever, basketball or whatever it is. What is it? You're not going to play Clash of Clans either. So, yeah. So anyway, let me know if you want to use your tablet for note taking, and we can talk. Next, back page. So once again, pretty boilerplate, but I do need to mention these things. So inclement weather policy at the top. If we close, which this week is a little rough. Like this morning was a little chilly, but I made it here nonetheless. But if for some reason we're closed, I still will always have class online asynchronously. So if we close for any reason, if classes are canceled, check your email. I will give you instructions. So there's that. You've got the grade there. Oh, I'll be on campus too if we're closed. On most days we're closed, mainly because that's what I've always done, and I feel like at this point I need to be consistent. So I bike over here when it's snowing, and it's kind of like just to show off that I can do that. But anyway, getting back to this, you have the course grade made up of exams, pretty standard, what you would expect from me. So 3 exams, practice exams and all that, don't worry. Daily assignments, daily quizzes, other class activities, and then the comprehensive final exam will be on the 29th. Let me double check this, because I have at the bottom, you'll see the final exam schedule. It says classes begin at 2:10, is Tuesday, April 29th at 1:10 p.m. I know I say 1 o'clock there because I think it's silly to come at 1:10. I'll be here probably at 12:45, but you can start at 1, I don't care. So you can see that, the standard breakdown. Let me just blow through these last items that, once again, legally required to do. And some faculty don't talk about these, and they apparently get into trouble, not with the feds, but just it causes problems. So bear with me for a minute. Academic integrity, if you cheat. Also AI issues here are listed. But you can go online to check out our academic integrity policy, but I'll just do the quickie version. Is if you cheat, I have to contact the powers that be. They tell me if it's a first, second, or third offense. And if it's a first offense, well, in any case, I have to meet with you, which is so uncomfortable. I don't like doing it. Please don't make me do it. So I will meet with you. I will have to have a conversation, difficult conversation. We will talk, and then I will write a report, which I don't like writing reports either. And then if it's the first offense, basically I have to figure out what to do. But generally, it's just a 0 for whatever assignment it is. If it's the final exam, it's really bad. So don't cheat on the final for sure. If it's the second offense in university-wide, so that's why I have to contact the powers that be, is they'll let me know. Second offense, it's out of my hands. I write my report, then they deal with it, and generally it's a 0 for the course. So they take a pretty dim view of cheating. And then if it's the third offense, once again, out of my hands, I write my report, then they kick you out. So that's it. We don't want that to happen, so don't cheat. Accessibility services, you've all been here for long enough to know what that means, but please do use them. Titles 6, 7, and 9, just if you experience any sort of discrimination that you think is unfair or based on anything other than just the fact that you, like, I guess we discriminate all the time based on your abilities and how well you do your work and that sort of thing, but that's legal. It's illegal if we discriminate because we don't like you or whatever. I don't know. So anyway, please do be aware that there is a reporting form that you can click if you go online and get the syllabus. It's on our Moodle page. And in addition to that, you can go to the Office of Civil Rights and I can help you find it if you need me to, or you can ask someone else. One note, though, about Title IX reporting is that we are all, that's the last bit just before the final exam schedule. You can read that over, but essentially, we're all mandatory reporters. So if you were to disclose something that fell under Title IX issues, like anything, I don't know, crimes involving, discrimination in certain situations, I would be required to report. And if it was a crime that was bad enough, I would have to call 911 immediately. But anyway, just be aware of that. And this includes when you disclose things in like papers and stuff. I was talking to colleagues in the English department, and apparently it's tricky for them because they don't. I told them, why don't you just give them this spiel at the beginning, and then they'll, like, students, if you just avoid certain topics in your writing, then we don't have to worry about it. But yeah, it's not an issue for us, because what are you going to disclose when you're solving your differential equation? I don't know. I don't want to make light of it. I thought of a joke that would be funny, but I will not say it. So you can fill in the blank with whatever you'd like. But anyway, yeah, so there are places, there are offices on campus that you can access if you need to. In particular, the counseling center and the spiritual life office. But there are also some faculty members who are ordained, and because of that, don't have to be mandatory reporters. So if you really want to disclose something, but you don't want it to be reported to the police, I can let you know who those people are, or I can help you find them. So that's it. All right, I've done my duty. What questions do you have? What worries, fears? And you'll find your friend, this, I forget her name, but you'll let her know. She needs to go. Okay, well, let's move on then. Certainly, if you have further questions, we can talk about them. Let me show you the website really quick, because you're going to have homework. You will have homework for Monday. So, sorry. Let's see. This is this differential? This is differential here. Okay, yeah. So on our website, there's not a lot there right now. We've got the syllabus, the aforementioned syllabus with all the links you can click. You've got class videos that takes you to my influencer account that has on it. Let me just show you what yours are going to look like. Yours will look like this. So I don't know what happened here, upcoming. So this is the one that all of the differential equations will have this beautiful gold background. And I'm going to try to do better this semester. I will put in the title what we're doing on that day. So if you're looking like through for the old videos of like, when did we do separable equations? Well, we're going to do it Monday. Well, probably not Monday. But anyway, you'll just look for separable equations down there. So that might help in the future. Let's see, what else do we have? Yeah, I don't know what this is doing here. Okay, so we got the syllabus. Here it is, the homework. So the homework, you will find one item on the homework. I thought that this was, just a minute. Let me just change to a student role, so I can be a student. Okay, just so that I can see what there. So this is what it looks like for you. I'm gonna, at least for now, I thought this was kind of a cute thing. I was looking for something in Moodle that would allow me to easily make a list of the homework, and instead of, I used to go into the HTML and try to make it look good, but this seems like it'll be good. So I'll just put all the homeworks here. So this will be for Monday, and you can check it off when you do it. and keep track of the homework you've done and the homework you've not done. Look at that. I've done 100% of the homework. So, but anyway, I thought that was kind of cute. But of course, the unfortunate thing is, as I add to this, you might have 100% one day and then the next day 50%, you know, because I'll be adding things as the days go on. But there's a short assignment on Monday, and hopefully if you don't have this book, you have friends in here who do have this book. And if that's a problem, if you don't have the book and you can't get a copy access before Monday, come talk to me, and we'll do our best. Okay, so differential equations. I know you're thinking, what are differential equations? And so to help you understand what differential equations are, I want you to invent an equation for me to solve. So come up with an equation, hopefully not too hard, and we'll see if I can solve it. So I'll give you a couple of minutes, minute or two, you can talk with your friend, but make sure that you know what the solution is. So you can't just make up some piece of garbage that's completely impossible. All right, I think you've had plenty of time to come up with some devious thing for me to try to solve. Adric, what kind of equation do you have for me? 2. That's not even an equation, so you've already failed. But this is not an equation. That's an expression. So I guess I didn't think I would have to review what an equation was, but this is good. This is good. Definition of an equation is something with an equal sign in it. And if I'm going to solve it, it should have some unknown in it as well. So that was just an expression. I can tell you what it equals. And now I have an equation, but before that equals was there, it's not an equation. So excellent. Thank you for I mean, that was helpful to know. Equations, usually you're going to have some sort of an unknown. I know Haven has one for me, don't you?
Okay. Do dy over dx equals x over 1 plus x squared.
X plus what?
Oh, it's x over 1 plus x squared.
Oh, x over 1 plus x squared. Okay, very nice. So that is an equation, but that's a very special kind of equation. We're going to get to that equation. That is an equation that I would call a differential equation. So we're actually jumping. So we've gone from not even having an equation to having a differential equation, which I guess is good because we've hit all the definitions I was hoping for. So equation, we know what it is now. That's a differential equation. We'll explain why that is here. Let me just show you. I actually have one of my next slides is invent a differential equation for me to solve. So I'm going to just write this down. dy over dx is x over 1 plus x squared. Is that what you had, Haven?
Yeah.
Okay, yeah. So that is there's a reason why I'm going to call that a differential equation. But I'm hoping to get at least one bona fide non-differential equation to solve. So let me try one more time. Let's see. So we got, let's see. No, I keep getting this same clot of people over here. Claire has one though. Claire, what do you got?
Sine of x equals arctan of plus 1.
Ooh, sine of x is equal to arctan of x. Ooh, fascinating. Do you know the solution?
No.
Okay. I was hoping it had a solution. Yeah, the plus 1 is what's messing me up.
You can take that off.
Yeah, well then it's easy. The answer is x equals 0. But yeah, so I guess, I mean, you know that what this is an equation is you're looking for what does the value of x that will make this statement true. Maybe we can get one more. By the way, that's not the only solution to this equation. That's just the easiest solution. And I didn't say I would get all solutions. So
I'll just give you the 1, the x equals 0. So let's see if we can get at least one more equation here. Why? Why does it love this group of people so much? Rachel, Jay. Oh, nice. That's okay. I've got it solved even before I wrote it down. But you did too, didn't you? Is x equals -1. Very nice. Thank you for having a nice, relatively easy equation. So to solve that, you would have either use the quadratic formula or you would factor this into x plus 1 quantity squared. Very nice. It's a beautiful equation, by the way. Very nice. By the way, did anyone have equations that had more than one letter in them? You did?
Yeah.
Well, what do you got?
I got x to the third plus y to the third plus z to the third equals 42.
Okay, and I assume you know the solution to this? This actually has an infinite number of solutions, of course.
I know one solution.
Yeah, so 0, 0, and the cube root of 42 would be one solution. Oh, there's an integer solution? Is that what you're telling me?
Yeah.
Oh. Wait a minute. That makes it more interesting.
You won't get it.
I won't? Because there's a negative in there.
There's a negative.
Yeah, okay. Oh, fascinating. I'll save it. Save it for later. I don't want to waste time. Okay, so we're looking for that. Okay, just a minute. So this is, so because I didn't specify, so that is actually, if you're looking for integer solutions, it's a subset of equations that are called Diophantine equations. And Diophantine equations are just equations where the solutions are all integers. And so that's actually a fascinating thing. I'll figure it out and I'll let you know. You don't think so?
No, I don't think so.
The article said it took a while.
Oh, really? Oh, this comes from some article.
Yeah, it says it took over 1 million hours.
Of computer time.
Yeah.
Well, but that doesn't. Oh, okay. So there's probably some big negative number.
It has like 16, 17 digits.
Oh, that's sad. Okay. Okay, I probably won't. Yeah, and especially if it's getting 60, I won't even bother trying to write it. Okay, but okay, I'm going to stick with my original solution then, is that x equals 0, y equals 0, and z is equal to the cube root of 42. Since we didn't specify at the beginning that this was a Diophantine equation, so there's my answer, and there's other answers, of course. Okay, well let's go on. Let's get the definition. We'll get to this one though. I like this one. This one's an easy. This one I can solve. Yeah, I've got it solved now. But let's just take a look at what the definition is. Definition of a differential equation. Differential equation is an equation. So you know what equations are now. It's an equation that has derivatives of one or more unknown functions. So that's all it is. It's an equation that has derivatives in it. So much like that differential equation that you showed me just a minute ago. So this thing here is a differential equation. Now I know it says with respect to one or more independent variables, but I guess we need to specify what we mean by independent and dependent variables. We'll get there in a minute. I think you probably know, but I've got a slide here somewhere. Where is it? Yeah, we're getting a little ahead of myself. Yeah, I'll show you that slide next. But first of all, let's get back here to this differential equation that you provided to me really easily. Nice, well described here. So I say that this is a relatively easy one to do. I think most of you could solve this one as well. I know it looks scary because of that dy over dx, but that is why this is a differential equation. This is the derivative of y of x. So differential equations are just equations that have derivatives in them. And what we're solving for is we're solving for the function. So I assume that's what you meant when you told me to write this down, is that we want to find the solution to this. In other words, we want to find the function that this corresponds to. So to do this, I think, I don't know, I mean, I would hope that you could all do this, but let me just point out this, that y of x is going to be the integral of this. So this is a differential equation that you already know how to solve. It's just the antiderivative of that expression. And that expression is not a hard expression to do the antiderivative for. Notice that this, you could use u substitution. Do you see it? So if you let u equal this, du is equal to 2x dx. So then you just have to deal with the 2 because there's no 2 here. And the final answer is just going to be the natural log. Give me a sec here. Well, 1/2 because we have to have that 2 go somewhere, times the natural log of the absolute value of 1 plus x squared plus some constant. So that wasn't too bad. But you could get crazier than this for me, couldn't you? That is a, here, let me show you something. Because it is so onerous to have to write dy over dx, it sometimes is more convenient to write like this with prime, doing prime notation. Those are the same differential equation. So can you come up with another differential equation? Maybe something a little bit more convoluted. And this one, of course, you don't need to know the answer for. So don't get too crazy though, but it'd be nice to have a little bit of variety. So I'll give you a minute. You can think of something. By the way, when I say, here, let me just go back to this definition, because I want to emphasize something that'll be interesting, is it has to include, where is it? The derivatives of one or more unknown functions. Notice that this is plural. That means that you could use the first and second derivative in the same equation if you want to. You could also put the original function, so I could do y is equal to y prime. In fact, I'll write that one down as a very simple differential equation that you all can probably solve. And so here is another. So here, the top one is the first one that I could solve pretty easily. This one, I think all of you could solve. And if you can't, I will help you. It's not hard. So I need a couple more because I don't have a lot of room on here. But take a minute, see if you can come up with something that involves a function and its derivatives and maybe some other letters. I don't know. So I'll find a couple volunteers. Okay, I know some of you are still thinking, but I know Connor has something that he's just dying to share. What do you got, Connor? Oh, is that right?
Oh, sorry, that was my last name. Sorry.
Andrew! Why did I think Connor? It's your last name.
That is my last name.
I just popped in my head. I looked at your picture, and I didn't look at the name. Go ahead, Andrew.
This is for the embedded differential, right?
For what?
The embedding and differential.
Yeah. Invent a differential for me.
1 plus sine squared of x, 1 plus sine squared of x over x plus 2 is equal to y prime.
Over what?
X plus 2.
Okay, good. That's a differential equation. It meets the requirements. It is an equation, and it has one or more derivatives of a function. I'm assuming that y is a function of x. So when in doubt, if it's not explicitly put there, then you have to assume that your y is a function of the independent variable. Okay, let's get a couple more. See if we have, Cooper, do you have one? Okay, whoops. Okay, so here, 3x squared plus 6x plus 6. Sorry, I just realized that was the other Cooper. There's two Coopers. But we can do both Coopers then. All right, Cooper Stiegel, do you have one?
Let's just do cosine squared x plus 5x cubed equals y prime.
Okay, so far, whoops, is equal to y prime. So far, all of these equations, they're all differential equations, but they're kind of boring to me. And the reason why they're boring to me is because they're all just the derivative. I mean, this one here, this is the derivative of a function. You're just going to do the antiderivative of this to get your answer. I know that's going to be a pain to do, but same thing with this one. I'm going to just do the antiderivative of this to get my answer. See, this is different though. Do you see how this is different? I can't just do the antiderivative of this to get my answer. This is a different type of equation. So here, same thing. So maybe we could get at least one or two that have both y and y prime in them, or maybe throw a y double prime just for fun. So here, I'll give you another minute to think. Maybe throw in a couple of extra little things to make it more interesting for me. I mean, these are all differentials. I just, want to make it more fun. So I'll give you another minute. All right, let's do this. Tyler, what do you have? Do you have any good differential equations?
Y prime is equal to 5x squared over natural log of 5y to the fifth.
Ooh, oh, I love it. Just a minute. Y prime is equal to, what did you have there again?
5x squared.
5x squared over the natural log.
Of 5y to the fifth.
Ooh, so it's all inside like this? Oh, that is a differential equation. Oh, I love it. Okay, that one's beautiful. Very nice. That one I could solve. Yeah, that's a nice one. Yeah. Okay. It would take me just a minute, but we won't. It's a special category of differential equations, which you'll be able to solve it next week. It's this. I know it looks crazy, but it's not hard. Okay, let's get a couple more. Caden, what do you have? Do you have a differential equation that has something more than just y prime in it?
Oh, no.
No?
What do you got, Luke?
What do you got? Does Luke have one?
Y prime squared
Ooh, oh, I love it. Thank you. Y prime squared
equals arctan of x over sine of y, and then plus 1 outside.
Oh, that makes it so hard. Okay, that one, no, we will not be able to solve next week. But yeah, that was beautiful because that's going to give us, oh, I love this. Okay, one more because I have enough room for it. Because we're going to categorize these as, because knowing what these things are called, you'll know that next week you'll be able to solve this. Whereas this one is special, it's hard because of a certain thing. Matthew, do you have something new, another one for me?
Y prime equals x squared plus x minus y double prime
Oh,
over
minus y double prime?
yeah,
I love
over
it.
natural log of x squared plus x.
Oh, that's so good. Thank you. Now we're getting somewhere. Minus y double prime over, whoops. The line is, oh, come on. It's only on the right side, I assume. Is that right? Like this?
Yep.
And then what's on the bottom?
Natural log of x squared plus x.
Okay. Nice. Yeah, that one's going to be hard. So yeah, that one's going to be a problem. So, but yeah, that one is easier than the one to that's left. So, oh, this is so good. Good, thank you. So yeah, this one's the hardest, I think. But that one, you have a second derivative in there. That's beautiful. So anytime you have any derivatives, we're talking about. Now, let's go back to this. Does anyone know what the answer is to this one? What? Did someone whisper it? It is. How did you know? So you knew it because, well, I'm going to just pretend, I don't know what you were thinking, but you're looking for a function that is equal to its own derivative. That's what this says, right? And what function equals its own derivative? E to the x. Very nice. That's not the only function that works, though. Can anyone think of another one? What do you think?
0.
Oh, nice. I wasn't even thinking of that. I like it. 0 works. Yeah, there are more. There's 0, there's e to the x, and there are others. We'll get to the others in a bit, though. It's not that big of a deal. But yeah, the e to the x is, so we could do one more. No. But you could think of this as we're trying to find the function that's the answer to each one of these. Just like what Haven did up here, e to the x is the right answer. Very nice. So let us get to, let's see, where is it? Oh, I know, we're going to do, I said that I was going to do this, skip this. Yeah, we're going to do this. Yeah, okay. So this is a typical differential equation. I'm showing you this one because this is the one that's going to make you the most uncomfortable. And so you have, whenever you're dealing with differential equations, you need to be able to identify which variable. So here we have two variables. Which of those variables is the dependent variable and which is the independent variable? You would be probably a lot more comfortable if I had written this way. Y double prime plus 16y is equal to 0. But I didn't, because oftentimes, especially when we're dealing with differential equations, our independent variable will be time. And so here it's just saying that you have some function x of t, so that's this thing. X of t is the solution you're looking for. And I'll tell you right now what the solution to this differential equation is. The solution to this is x of t is equal to the sine of 4 times t. So that's the actual, well, that's one solution. There's more than one, just like 0 is a solution. But anyway, so x of t is sine of 4 times t. By the way, cosine of 4 times t is also a good solution. Just think about it. What's the second derivative of sine of 4 times t? It's negative 16 times sine of 4 times t. So the second derivative of this plus 16 times this is 0. So this is the sort of thing that we're going to be dealing with. But the reason I put up here was not to impress you with my skills at solving differential equations, but rather to note that you have a dependent variable, usually was y in the olden days, but now it could be x. And an independent variable usually was x in the old times, but now we're going to use t most of the time for our independent variable. So x is a dependent variable here. So don't let that throw you when you see it. Let's see. So do we want to do definitions or do we want to talk about baseball? Let's talk about baseball just briefly. Just briefly. So here is a problem that you learned about back in high school physics, or maybe not until general physics here, I don't know. But you could solve this, couldn't you? A baseball is launched at a 45-degree angle at 50 meters per second. That's 112 miles per hour, if you wondered. How far does the ball travel? So you understand the problem, right? You're launching the ball. We know about the acceleration due to gravity. We can figure it out, can't we? Vectors and all that. You probably have formulas. You have formulas, don't you? I mean, we could do this. There's a bunch of different ways you could do this. So in high school physics, you would learn about this and you would work out the acceleration due to gravity and how far it goes using that. Unfortunately, high school physics, here is, I do have the high school physics answer, but I don't have it without any of the differential equations. So the unfortunate thing about high school physics is, and for that matter, university physics, not all universities, but some of it, is that it ignores the fact that we live in a world where there's a lot of air, right? And so when this baseball is launched at a 45-degree angle, we just assume that it's not going to slow down based on the wind resistance, right? You just figure the only force that is acting on the ball is gravity. And so it goes up, it goes down, perfect parabola, right? Beautiful, perfect parabola. You've probably seen this sort of problem back in Calculus 1 in high school physics and maybe even university physics. That's not reality. Reality is that there is air. The air slows down. There's an actual force that we can describe using differential equations, which I'm not going to do right now. But I will show you the differential equations. Here's reality, is that you have the mass times acceleration. That's the force, formula you're familiar with, mass times acceleration. Here's the force due to gravity, negative 9.8 meters per second squared times the mass. And then this is the force due to wind resistance. So air resistance causes this, and you have a similar situation in terms of your x variable. So how high, how far, y is up, down, x is left, right. And we can actually, I looked up the coefficient of whatever, air resistance, what is that called? Coefficient, why can't I think of it? Anyway, the air resistance for a baseball. And the mass of a baseball, I got all the numbers together, put them together into this equation. These are my solutions, by the way. You get a parametric set of equations for the solutions. But this includes air resistance. Now, let me show you the difference between high school physics and differential equations. Here's high school physics. High school physics predicts this beautiful parabola. The baseball is not only hit out of the park, it's down the street into the next state maybe. So this is huge. I mean, it's 260, almost 260 meters is the distance that the baseball would fly according to high school physics, which is a huge, that's like 850 feet. It's huge. Here's reality, and this is a little bit closer to, if you watch baseball, which I don't, but I've been told that this is closer to reality, is that the ball goes up, but you can imagine air resistance slowing it down. And so this is the actual graph of those two equations that I had on the previous slide. The ball falls just short of 100 meters, which is about 318 feet. And that would be a home run. Wait, what's a home run? Depends on the park, right? Because there's no standardization.
That's around like 400.
Oh, 400? What is Boston, Fenway? Isn't it short? Aren't there some short parks?
I mean,
There's some
left and
short
right
ones.
field would be a little shorter, but that's going to still be like 350.
350. Okay, so perhaps this is a pop fly. They get out. They're losers. So apparently they need to hit it a little bit harder next time, and then it'll go. But yeah, so it's hard. It's hard to. But this is absurd. Right? I mean, that's just like down the street. So, but anyway, that's the difference between high school physics, and that's why we're studying differential equations, is because it's closer to reality. Okay, so what is this? I just want to see what we need to talk about, what we don't. Just a few things. Just some definitions. We're not going to dwell on this. I want to get to the stuff that's on your homework. So just so you know, ordinary differential equations are what we're focused on. There's only one independent variable. Okay, there can be more than one dependent variable, but there's only one independent variable. That's why we generally have time as our independent variable. Let me just go back quickly. Notice that here, I don't even have the independent variable here, but it's time. So this is the second derivative of y with respect to t. This is the second derivative of x with respect to t. So that's what we're dealing with here, is you have the time. You have two dependent variables, one independent variable. So not a big deal, because I'm not going to ask you about this really. It's in the first chapter of the book, and we aren't doing, this is just, I don't know. We aren't going to do partial differential equations. Partial differential equations are more than one independent variable. So we're not going to do that in this class, because it gets really complicated. So that's something else, another class. Okay, next thing, just a quick note on notation, Leibniz notation. Whenever you have, well, let's not do it that way, dy over dx, or d squared y over dx squared, or d cubed x over dt cubed. Those are all Leibniz notation. So this is the fraction, the operator notation. That's Leibniz notation. So you'll see things written like that, but prime notation is just more compact that you'll see. So like y prime, y double prime, x triple prime. The problem with prime notation is that you don't know what the independent variable is. It's just the dependent variable. But if you know, like if there's some other clue as to what the independent variable is, then prime notation is fine. I like prime notation just because it's much more compact, easier to write. But just be aware, these mean the same things. So these are the same things. So if you get confused, though, just let me know. I should mention, though, even though, well, do I have it? Yeah, I do have it. Is that when you do physics and certain engineering situations, you'll see dot notation. So you'll have something like that, which is the same as x prime, which is the same as dx over dt. This is Newtonian notation. Newton was into the dots. So he would have these like double dot for second derivative. So it's just a holdover from Newton. I think prime is more descriptive. There are certain settings where the dot means something slightly different than the prime, but I don't think we're not going to worry about that. Okay, so we've already done this. Okay, so finally up to some definitions that we care about. Order. So the order of the differential equation will affect how we solve it. So by the way, this is a first course. Yeah, I guess that's the same. This course is divided into sort of two types of things that we're going to be doing. We're going to be learning how to solve differential equations like this, and we're going to be learning how to create differential equations like this. And by creating them, I mean, how do you look at a problem and decide that a differential equation would be a good way to solve that problem? Like the baseball problem. How did I know to use, yeah, there's certain hallmarks that will dictate that you use a differential equation. So there's both of those things going on. But anyway, in order to solve a differential equation, we have to be able to classify it by order. For example, here this is a second order differential equation. Second order because the highest derivative is the second derivative. So let's just go over to, and then this first order differential equations are oftentimes written in this form. I'll show you a better example of this in just a minute. Let's go back to the examples that I had that you came up with for me. So we have the order of the differential equation. This is first. This is first. This is first. Most of these are first order until I got you to do something. So this is, first. I'll write it out. So all of these are first order differential equations. First. Second order. So second order differential equation because there's a second derivative. The way you solve second order differential equations is different from the way you solve first order differential equations. We will use techniques for first order differential equations to solve the second order differential equations, but it is harder. So we'll focus on first order initially. Okay, so there's that. Let's see, there's one other word I want to make sure we get because I see we're running low on time, and that is the word linear. So linearity, what does that mean? Linear, let's see, I've got, this is so ugly. Yeah, I guess this works here. Yeah. Okay, yeah, this will be fine. So linearity, here, the easiest way to look at this is to think in terms of the function and its derivatives. Yeah, that looks terrible. Here we go. Linearity. Linear means, let's see, y prime, y double prime, y triple prime, etc. are just linear. Linearly combined. So here, y prime plus y double prime plus y triple prime is equal to y. That is linear. I could put x squared here, still linear. All we care about are the function and its derivatives. I could put cosine of x at the front, still linear. I could subtract off e to the x, linear. But if I add the natural log of y, not linear. That would make it nonlinear. So when you're trying to figure out if a particular differential equation is linear, ignore the independent variable, just look at the dependent variable and ask yourself, are those all just linear? Let's go back, and I guess this will have to be it, but it'll be okay. So let's look at these. So most of these are linear, but there's, I guess, just one. One of them is nonlinear. So of all of those that are boxed or circled, they're all linear except for one of them. Do you know which one? Can anyone identify the one nonlinear? Oh, no, I'm sorry. There are two. I just noticed. Two nonlinear. My bad. So if you were confused, there are two nonlinear. So which ones? Does anyone see them? You got one? Oh, the two in the middle. Yeah, yeah. So this one's nonlinear because you have the natural log of 5y to the 5th power. Nonlinear. So that's not linear. This one's not linear because of this. You're squaring y prime. So nonlinear. Very good. Okay, so your homework, you saw it, it's online, it's in the book. It's mostly definitions. I'm not confident that I've hit every single definition that I was supposed to, but I'll bet you can figure it out if I didn't cover every single definition. There might be, I don't know, there might be something that I missed here, but we'll deal with it on Monday if need be. Oh, yeah, there was one thing. Yeah, solutions. Yeah, how about this? We'll have this homework due on Wednesday. So you can start it. It'll be fine. You'll go through the definitions super easy. We'll have the homework. First homework will be due on Wednesday. Then no one will be frustrated. You have time to get your book. I'm going to turn off the recording so that if you want to come chat, you can. Otherwise, I'll see you